I don't know if Dhananjay joined. No, okay. Let me take this up then. Say this is a machine learning concept, okay? It comes from the machine learning itself. It is there in the machine learning. Uh, so, uh, so let me try to explain with the diagram. We have the x and y coordinates. Let's say we have some distribution of data, okay? So you're training the model with this data, okay? And model learns as per the data. Then it will go like this, go like this, go like this, and learns like this, okay? It does the overfitting, okay? Means it learns those data exactly, learns from the data, okay? But you don't want this to happen, because tomorrow if somebody a new data point comes here, uh, it won't be classified properly, or the output will not be proper, right? So that is where you add the bias when you, Vishnu, you want to say
No, no, no,
something?
bro. No, yeah, go ahead.
No, I'm trying to say, but it's a difficult to explain. So when you add the bias, what happens is that it becomes something like this. Okay, so maybe you can read this thing, um, or maybe let me show something.
You can share the links of these conversations, Pavan. We'll take a look. We can move next. I'll read and come then, if it is taking time.
No, that is okay. We have to understand these things. So then only it will be more clear and easy to learn. Okay. So there was one sentence this guy told. This one you see. Um, so when you train the data, bias says how confident or aggressive the neuron should or the model should learn from it. Okay. Um, maybe I'll find a better video of the bias, and let's come back. We'll search and check and come,
Yeah, that.
because it's.
You mean the definition of bias?
So sorry, Vishnu, I didn't get you.
So basically, you will be explaining the definition of bias here again to Vinal or team. Like what exactly?
No, I was trying to explain bias. Okay,
Okay,
I
okay,
mean
okay. Oh, okay,
the
okay.
same thing what Dhananjay was
Mm-hmm.
explaining. Since Dhananjay
Got you.
joined late,
Got
I
you.
was just trying to explain.
Mm-hmm.
So the idea is it should not overfit or it should not underfit also. Okay, that is why you use the bias. So if you put the high bias, then it will not learn. Okay, it will not learn only. It will learn very little. But if you have the low bias, it will learn too much from the data, and the model will fit completely into that data.
Mm-hmm.
Okay. So we don't want that also. That overfitting we don't want, because that's not something when the new test data comes, then it won't give us the proper answer, right? If it is overfitting. So that is why we try to generalize it using the bias.
Yeah. So Vinal, everyone, right? So in very simple term, okay, bias is nothing but like you have to make sure uh, bias doesn't have to be that high, which will make the model overfit. Okay,
Hmm.
that's a one statement. And you don't have to make bias less also, because it will make the model underfit. Okay, so overfit means model has learned more. like what is expected, but he has learned more than what is. But he's supposed to learn 10%, but the model has learned about that use case more than 10%, not 20%, 30%. That is overfit. Okay. Now, if we ask model to learn, but he is unable to learn even to the 10% what we are expecting, like he has only learned 2%. In that case, it is underfit. Okay. So bias has to be the like a kind of a knob, like it's a very simple term. It has to be very much tuned enough so that it will be consistent. Like what I think the picture what Pavan was showing earlier in one of the PPT slide. In each of the layer, we will be adding a bias so that bias with a weight. Okay, weight is like okay, which direction exactly it will be going. If that direction, if we are getting a proper output, the weight will be more. Accordingly, it's a kind of a hidden layer. Okay, what exactly the hidden layer? Okay, hidden layer is nothing but it's a it's a layer where exactly the processing is happening. Like what exactly my output will be coming out from these multiple layers of what DNN is. So multiple layers adding weight to each of the layer, and in the last we'll be adding a bias. We'll be getting output. So this processing layer is called hidden layer. So under that only it is all things are getting processed, but yes, parameters we can provide it. So bias is nothing. It has to be very controlled, or it has to be knob in a very controlled manner so that model will not learn more or model will learn less. It has to be very optimal, equal, like kind of what our expectation is. Very simple term. We can brainstorm more. Yeah, Vinal,
Yeah,
Arun, Dhananjay,
right,
Pavan.
Yeah,
Yeah,
I think
right.
yeah, maybe little later we can brainstorm more, maybe in the next sessions or so, and we can
Right.
correct.
continue on the next slide.
Agree,
Okay.
agree. Yeah,
Yeah, so the neuron in AI terms, right? We call it as perceptron. Okay, that was the name I think it came. It was given during those days. So it has the summation, weighted summation here, and it will have the activation function. Like I said, right? Simple activation function is like if the summation is greater than 0, the neuron will fire or the perceptron will fire. The output will be 1. Okay. Um, this is a sign function here. It can be anything. There are different activation functions as well. And if the summation is less than 0 or equal to 0, it will not fire or it will give the -1 as the output. Okay. Yeah, this is full a picture of one single neuron. It has the inputs, weights, and then the summation function, activation, it's called hypothesis, and the output. Okay. Now, you can solve the and we all seen, right? And or NAND nor we have learned all these functions, right? Boolean functions. So all these functions, right? And or NAND nor these can be solved with the single perceptron. Why? Because they are all linearly separable data. Okay, that I'll show you what do you mean by linearly separable. So if you see here for not 0 output is 1, 1 output is 0. Okay. Uh, yeah, let's say okay, AND gate. Let's go with AND gate. Okay, I have the graph here. So for AND gate 0 0 0 0 1 0 1 0 0 1 1 1. So if you plot that, right, um, uh, it will come here 4 points. I can't take the pen. So one is here, one is here, one is here, and one is here. Okay. Now uh, when it is 1 and 1, the output should be 1. Okay. And all other cases, the output should be 0. 1 and minus 1 in the sense you can think of 0. And the other one also 0 and 1, it should be 0. Okay. But only one place here alone, the output should be 1. Now, if you plot it in the two-dimensional graph, because it is two-dimensional, A and B is the input, uh, you can clearly see that you can put a line here. Okay, put a line and you can separate the output when it is 0 and when it is 1. Okay, so this is a linearly separable output. Okay, so when it is a we can linearly separate the outputs. Then a single perceptron can solve it. Okay, the solving is bit. How do you explain this?
I read somewhere that each neuron or each perceptron is a linear regression unit.
Yes, you can think of that. Yes.
Okay.
So the idea is like linearly separable outputs, right? You can represent or you can solve it with the perceptron.
And if it
Because you
is
can put,
not a linear regression problem, then how will you solve it? You will use multiple perceptrons then in that case?
yes, you will use the multiple perceptron. That's where the XOR comes. Okay. So uh, uh, say this one. So if plot this XOR, the XOR what happens 1 1. When it is 1 and 1, what is the table, man? I forgot XOR also.
If it is
Uh,
opposite, I think it's one. If it is the same, it is zero, something like that, right?
Correct. So now
Correct.
here it is like this, right? Say blue is 1 and 0, this red is 0. Okay, now how will you separate this? You can't separate this with the line, right? You can't separate this with a single line. Okay, you need two lines,
Hmm.
Hmm.
right? That means that you need two linear functions. That means you need two perceptrons.
Hmm.
Yep.
Two or three? I forgot. Is it three, right? Yeah, three.
Uh,
Yeah, totally
Madam,
three. One is
can you
output
explain me
layer.
again the last one? I I missed it, man. Last concept.
Which one?
That XOR gate. How exactly the perceptron will decide? It will be using a XOR gate
Yeah,
for
correct, correct.
the.
Yeah, so it's here, right? So 0,
Hmm.
0, 0, 0, 1, 1, 1, 0, 1,
Mhm.
1, 1, 0. Okay. So when you plot it, it is not linear
Mhm.
here. Okay.
Correct.
So you need two lines to separate it. Okay. You
Okay.
can't separate it with one line, one linear
Hmm.
line, right?
Hmm.
So
Hmm. Hmm.
you can't solve it with the one perceptron.
Hmm.
So you need two lines. So that means you need two perceptrons minimum.
Got you.
Okay. So this is how you solve the except this one XOR. Okay. You
Yep.
have one neuron here, one neuron here, and you have the output layer. So, but if you really understand the calculations, right, you will understand this. I'm not going into the calculations because that will take long time.
Okay, so Pawan, quick question here. So I understood that for representing XOR, while representing XOR on the graph between the inputs and outputs, we need two linear graphs, two lines to actually kind of establish a pattern, right? Yeah. Okay.
Correct.
So one line is like one linear regression unit is like one neuron. So you use two lines for two neurons. So it is a multi-layer perceptron, fine. But you mentioned it will
Right.
use three neurons. So what is the third neuron coming from?
Uh, I try to simplify it, okay, actually, with saying that two lines, two neurons, but it is minimum two neurons actually. So you see, one neuron represents this line, one neuron represents this line. Now you need to mix it, right? That outputs from this line and output from this line. Then only you'll get the final output, right?
Ah,
Because
okay.
because this line covers this red also here, right?
Hmm.
Then
Mm,
this line will come in and say that okay, this red is outside. So you need to combine the output of both the neurons, and then only you can get the final output. That's why you need third neuron.
mm,
Okay, so you can think like you need a minimum two neurons, because
mm.
minimum you need two linear lines to separate this. There was one good example, man. If I get, that's not there in this slide. When I get, I'll show you that. Okay, that makes very clear.
Okay. So for the
Uh,
But
sake of
I have
simplicity,
one doubt here.
Sorry.
Yeah, Vinal, go ahead. You complete your thought.
I'm sorry, yeah. For the sake of simplicity, we can say like, okay, we need another neuron to process the outputs of two neurons. Okay, okay. Yeah,
Correct. Yes, yes.
yeah.
So
Point.
I'll show you that that is there here. Okay, if you go into the next set, see when we will try to go in this multi-layer perceptron, right?
Mm,
Uh, we can actually see that. But again, we don't want to go into the calculations, because calculations will make you very clear. But unfortunately, it will end up taking a lot of time.
correct.
Okay.
We can postpone it for now. Yeah.
Yeah. So now you see, if any point falling on this yellow surface should be treated as 1, and outside this yellow surface should be treated as 0. Okay. So you need these many neurons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus again 3 more neurons. Okay, because I think there are 10 lines. Just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 lines. So you had 10 neurons, then you calculated the area of this bigger, whatever, pentagon or whatever,
Yeah.
with this first one, let's say the first one, and the output you got here. Okay. Then the second one you calculate it here. Then that output you got here. Then again you need to merge that to get the proper output here.
Mm.
Okay. So
It-
you can think like that. Think like it will check if the x1 and x2, this set of 1, 2, 3, 4, 5, will check whether the x1 and x2 is falling within this first area. Okay. If it is falling within that first area, the output will be 1. And the second 6, 7, 8, 9, 10, that is this line 6, 7, 8, 9, 10, will check whether x1 and x2 is falling on this area. Okay.
Hmm.
Then if it is falling on this area, it will say 1, but it cannot, both cannot be 1, right? Either 1 should be 0. Suppose if I have a point here, if I have suppose if I have a point inside the bigger pentagon, then
Hmm.
this one, 2, 3, 4, 5, when it ANDed, will say 1 and the other one will say 0. Then there will be an OR operation happening, because we have to add this. Okay. And then the output will be given accordingly. So this neuron, the hand neuron, this is the one which we saw there, okay, previously. Same way we can make the neuron work like OR also. Okay, this is the simple things. Okay,
It
means
Hmm.
graphically makes sense, Pavan. Yeah.
Yes.
yeah. So this, I mean, this and are all simple things. They are like sign functions. If it is beyond this, you fire. If you beyond lesser than that particular threshold, you don't fire, kind of. But there are other activation functions later we will see. But yeah, this is the idea. This was the something which makes it very easy to understand.
Yeah, yeah.
Yeah.
Each neuron working on the same level is called a layer. As the PPT says, a third layer is required. Okay, so uh, layers. Just read this word layer, so just acknowledging it.
Yeah, yeah. This is a layer actually. You will see that in the neural network. That's called layer. This is the first layer. This is the second layer. This is the third layer.
Hmm. Sure, man. Clear. Yeah.
Okay, guys. So, hey, can we
Uh,
stop here?
Pawan, I have one
Yeah,
small question here. Okay.
yeah, yeah.
Uh,
This question.
I might not like understand what exactly this particular graphical representation saying, but my
Ah,
simple question is like example, uh, if a perceptron, if we are using it, like okay, just to uh, I still stuck in that XOR gate, man. Okay. Why? Because
yeah.
instead of why we are taking two perceptron, why we cannot solve this problem using one perceptron only? Because that segregation will able to figure it out, right? Whether that red dot is above the single perceptron, above or below that single perceptron. So yeah, this one.
This one, right?
Something. Hmm,
Yeah, no,
hmm.
you cannot actually do that uh, because no, no, okay. How you will do that? I mean, you.
Vishnu wants to run a
Yeah,
line between the blue points, and then he says red are on either sides of the blue line. So
correct,
I
correct.
didn't
In
get
that
it.
case, it is linearly representation, right?
No, I did not get that. Sorry.
Okay.
What was that?
Okay.
actually,
So my question is,
Uh,
Pavan, that
yeah,
this graphical or the graph which we are seeing, which has a two
yeah.
lines here, which is
Correct, correct.
currently
Yes.
not linear. Okay. So you are saying
Uh,
this graphical line has been populated as per the reference of XOR gate. Is that correct understanding?
Uh, SOR get in the sense this one. When
Mm, mm,
this
ah,
is you have three neurons, right? So the neuron
mm.
one represents the first line, say.
Okay.
Neuron two represents the second line. Okay, like
Mhm.
that.
Okay. Where exactly this XOR comes in picture?
so
Oh,
So ZOR
ah,
is just representing the points on the graph. The blue and red
yeah,
points, that is what the ZOR outputs, inputs and outputs represent. These lines is
correct.
what we draw to reflect how many neurons we will need to process this kind of data plotting on the graph.
Okay, got
So
it.
when it is zero
Mm-hmm.
zero, when it is zero
Mm-hmm.
zero, a and b zero, I mean x and y zero, the output is zero here. When it is zero one, where is zero and one? Here zero and one, it is one. One and zero. This is one and zero. It is one. But when it is one and one again, it is where is one and one? It is zero. Okay.
Correct.
So the when it is zero, the color is red. When it is one, the color is blue. Okay,
Mm-hmm.
represented in blue color. So now we need to separate this, but
Mm-hmm.
this cannot be separated linearly.
So you are
So either
saying
you need to do
whenever we
like
will be taking the XOR gate, or if we are replicating a perceptron, it will be non-linearly in nature, right? Like in general terms, right?
no.
Pavan?
I
Like
sorry, I again missed that.
yeah. What I was saying, like whenever we will be plotting a XOR gate representing
Uh,
a perceptron, it will be always be non-linearly in nature, or if we are taking multiple neurons instead of two, we are taking one, or we are taking five, six, seven. So
hmm.
I'm not able to connect that dot, Pavan.
Okay, I'm really sorry. I am not able to uh,
Hmm.
uh,
Next question.
understand what you are missing. Okay.
I
Okay.
can tell Pavan what
Because
Vishnu is trying to say.
yeah.
Yeah, yeah, yeah.
What Vishnu
Yeah.
is saying is like you plotted you got these 4 points on the graph, right?
Ah,
So
ah,
now if
ah.
you have to kind of reflect this kind of data using perceptrons, you done it using the two linear regressions, two line graphs, okay, to represent this,
Yeah, correct.
to generalize this kind of data on the graph.
Correct, correct,
So
correct, correct.
two lines, uh, is this what you call a linear way of representing this data or a non-linear way of representing this data, since you're using two linear?
Yeah, correct. My
Ah,
question was around that only. I might not have expressed it in a better way. Yes, but yes, that's the intent. What Vinal has said. Told.
okay. Okay. I think I kind of understanding that, uh, but I don't
But
know
yes,
if I
if
really
you
have the answer for that. Mm,
correct, correct, correct.
One more,
but
I'm not
but
expecting answer, but you got the question
but you
right.
got the
So what I'm
question.
yeah,
trying
I
to say.
got the question.
One more question, interesting question which Vishnu
But
asked.
but uh, but I think see,
Mm-hmm.
when even though these two are linear, but you need
Mm-hmm.
minimum these two things to separate the data, right? So this is still be non-linear, okay? Why? Because
Mm-hmm. Mm-hmm.
just think of this. Just think of, like, I don't have a pen. Okay,
Okay.
just think of. Just think of this. Let's say the point is here and the point is
Mm-hmm.
here. The other
Okay.
point is here and the other point is here. But think of a different situation where there are multiple blue points here.
Mm-hmm.
There are multiple red points here.
Okay.
Okay. Now you need to separate this data like this.
Mm. Okay. Okay.
Okay. Something like
Mm-hmm.
this. Okay. Maybe this is a different set itself. There are five sets, you think.
Mm-hmm. Mm-hmm.
Okay, this will be still be a non-linear only. I mean, I don't know. I tried to I understood your question, but I'm trying to answer. I don't have a
Yeah.
proper. I
Yeah.
don't know how to
So
answer it properly. But
correct.
even though this is a linear lines or straight lines,
Mm.
still the still the what do you say? The problem is still non-linear only.
Yeah, that's what exactly I'm saying. That whenever we will be associating a perceptron with a XOR gate, in general,
Hmm.
our output or our representation in a graph will be always non-linear. Like it's a kind of statement,
Yes, yes,
Pavan.
yes. Correct, correct. Yes, correct.
So even if I take a hundred of perceptron with multiple neurons attached to it, I will be
Hmm.
getting a non-linear graph only. Like I am not sure whether this statement is correct or not, but you guys can pitch in here. We can, yeah.
Oh my God.
But
Ah, it is like this, right? Like you take 100 neurons, you can
Mhm.
solve the linear problem also, but you don't need 100 neurons
Agree,
to solve the linear problem.
agree.
One is
Yes,
enough.
yes, I do agree. Yes.
Yeah.
So whenever
Cool.
I am seeing a neuron, whenever I am seeing a linear regression unit, I see just a line to represent that. That's it. Nothing more than a line. I don't see a curve. I don't see a circle. I just see a
Mm.
line to represent that. And if you go to the slide
No,
of
no, no. Linear. No, 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 no. Linear regression is not just a line, not just a straight line. Okay, it can be a curve. It can, because if you see the
that
one
could be
second.
logistical regression, right? That
No,
couldn't be.
no. Both are same. Both are same. Both are same. Logistical and the linear regression both are same. It can represent the curve also. If
Mhm,
you see
mhm.
the thing here,
Controversial
I'll show you.
I head, at least.
13, 14.
Uh,
See, this is linear regression
Wait,
only.
wait,
There are
wait.
no
Oh,
powers.
sorry, sorry, sorry. My bad, my bad, my bad. Sorry,
Yeah.
sorry. Uh,
This could
yeah,
be
this you are correct. You are correct there. You are correct there.
I mean, unless you
You
have
are correct.
powers involved in your features, unless you have a quadratic equation involved, you will not
Correct, correct.
work.
Yes, yes.
Right? So,
Right, right, right. That's a different case itself. Yeah,
so
right.
that is also a neuron, right? That is maybe a logistical regression neuron. That is what you might call.
No, no, no. The logistic regression and linear regression both are ML based. There is no neuron coming in there.
Yeah, there is no neuron concept.
Okay, okay.
Vinay. Okay,
Oh,
so uh,
one,
yeah, so neuron concept is it's a what I forgot that terminology, Pawan.
no, but
uh,
no, but machine learning only, we
yeah,
have this algorithm called as a linear regression.
correct, correct,
and
correct.
and we are representing a neuron here with a linear regression as a linear regression unit only. So that is the
Hmm.
same, right? That even though you don't have the you do not call the word, you do not use the word neuron in the context of machine learning, traditional machine learning, I should say. But if you talk
Hmm.
about linear regression algorithm, that is your neuron only coming into play, right?
Hmm.
I mean, see, I know words. I'm just juggling around words to make a sense of things. Okay. So please
Yeah,
pardon me.
yeah, yeah.
I'm asking silly questions here. I keep on saying that. But one more interesting thing which Bishnu pointed out in the slide is, which if you go to the slide, Pawan, I'll ask that.
Which slide, man?
That Zor slide, okay.
Ah, this one, right?
Yeah, and this slide, see, this is the output. These are the points affecting the XOR output. It can be either 1 or 0, and you have plotted the points accordingly. Fine, that is fine. But if you're trying to draw lines on this graph to represent to reflect your patterns in the outputs, then rather than having two lines segregating the outputs here, you can have a single line passing through the blue dots. Okay, there could be only one neuron solving the problem for you in case of Zor's or specific problem, right?
No, no. If you pass it between through the 2 points, then it will cover only those 2 points. Other 2 points,
It will cover anything on those 2 points, right?
anything on those two. I mean, yeah, right. But it will not cover the other points, right?
Yeah,
So you're saying the line passes through one and one here,
yeah.
right? Then it will not cover the other 2 points. That is like you're mixing up both regression and classification. That cannot happen, right? I mean, you are
Okay.
trying regression in by passing one line, but again, you need to classify also, right? That these are not on that line.
So nothing on the line makes sense, but on the sides of line, what makes sense, right?
Um, no, I
So,
am. That's a good way of thinking.
yeah.
But
Even-
that there is a two decisions to come, Vinal. So you have one equation. Now you have to say that okay, the point is in this line also, and point is not there in this line also. The other points.
Mm-hmm.
I don't know. I'm making sense or not.
So
Um,
it's like a classification. Either you're on the line, then you're good, or you're out of the line, you're not good. Like
no,
suppose
no,
you,
but
uh,
think of this. Think of this. XOR is not just whether it is in the line or not the line. Let me draw it. Okay. So,
it is tough to
well,
visualize this because you
no,
don't
no, no, no.
have
I
that.
think that this one was not correct. But let's say I'll put a line here. Okay.
Mm.
Let me put a line here. Okay. So now it is not that it's, oh, how do you say? Um, Now this line has one equation, right? Y equal to some mx plus c.
Yeah.
So
See, my understanding till now was that whenever you train your model on the data, your model tries to draw a line to have maximum data points overlap so that when anything comes for prediction, it can extrapolate that line and make a prediction. That is what my understanding is. So when you are saying in XOR, you cannot
No,
have.
no. Okay, I'll ask you one question. So this is what you are telling, right? Put the line here between two these points.
Hmm.
Is that correct? Okay, then it will have one equation, right? Y equal to mx plus c,
Hmm.
right? Or
Hmm.
whatever, x, y, mx plus y. Okay.
Hmm.
So what this is z. Okay. Now, say for these 2 points, you will get the proper answer z. Okay.
Hmm.
But for the okay, I'm making confused. Hey guys, Vishnu or Dhananjay, you want to?
So
But these 2 points, how will you say that? Okay, you are saying that it can be out of this line. Huh? Hmm.
yeah. Hmm.
No, but just imagine this one. If I put a line, there is a point here, right? That falls on both lines.
Hmm.
How will you say when that point hits whether it is?
Now the gap here is, I know what the gap here is, but I want some way to fill that gap. Now the gap here is, since you represented the XOR gate with only four pairs of inputs and outputs, and you only plotted like 4 points. Okay, I am only able to visualize. Okay, there are 4 points, and if we pass a line through all the blue points, and we'll have the classification done with a single perceptron. Okay, but
No, no. I'll let you know why that may not happen. Okay, I understood your question.
okay.
I'll check the chat GPT and I'll let you know. I'm not able to answer that now.
All right, man. Since you
But there is some crooked way to do that, okay? But that's not something. I mean, even in the class, somebody did came up with some weird idea, but that's not something which can be done in a straightforward way. But yeah, this one I'll check, man.
All right, man. All right. I think we have only left with 1 minute to wrap up. So let's wind up the call for today, right? Uh,
Yeah,
and maybe for next call, we can decide on the group and come back.
sure, sure.
So we'll take it up from here. Today was a good discussion and a lot of new things. Uh, so yeah, all in all, it was a healthy discussion.
Yeah.
And Pawan, you
Okay.
paste the links of the bias one on your chat GPT, and one more link you had for machine learning and deep neural network difference. Okay. On chat.
If I share, is it readable for you guys? Last time I shared one ChatGPT link. Was it readable?
I'm sorry, I didn't click on that, so we can check that.
I doubt whether it is readable, okay, but I'll share it.
All right, man. Yeah, I think we can wind up now.
Yeah, okay then. Yeah, thanks everyone. Thanks,
Thanks a
Arun.
lot, Lisa.
Thanks, Vinod.
I'm able
Bye.
to see Pawan. Okay. Yeah. Thanks, man. Thanks, guys. See you next.
Ah,
Bye.
bye.